Afternoon, everyone, and thank you for joining us today. My name is Chris Probert, and thank you for taking the time out of your day to join us for what promises to be a really interesting session. This is the first in a series of webinars which we're going to be hosting in relation to knowledge graphs. It's a topic, that is a personal passion of mine and the people that are joining us today, and something which I think, is going to go a long way to addressing some major challenges in the financial services. So before I run into the running order, just to let everyone know, if anyone isn't familiar with Blue Jeans and the way that it works, if you look at the right-hand side of your screen, there is a column with a little speech box, a person, a few images there. We're going to be using that a little bit today. So there's a section for polls, and there's a section for Q&A. Even though this is a webinar, we are hoping for some interaction from the audience. So please, as we're going, raise questions. We're going to be reminding people as we go along. And if people leave their name, we will be able to hopefully get to all of them. If we can't, if you leave a name, we will do our best to get back to you. But today's webinar, we're going to have some introductions to our panel, to the people who are joining us today. We're going to talk a little bit around the introduction knowledge graphs, how they work. We're going to talk about some examples in the financial service industries, and a couple of us are going to go through some of our favorite, if you can have a favorite use case, what our favorite use cases. As many of you are new to this, and new to this topic, and graphs can be quite a daunting topic, we're then going to cover a little bit about how to get started, and then we'll wrap up with a panel Q&A with myself and the other people on the call that we're going to introduce in a sec. So to introduce the people that are going to be talking today, you're joined by myself. My name is Chris Probert. I'm a partner at Capco, and I run our data practice in Capco. I consider myself to be a bit of a data evangelist and a massive graph fan. We're joined, luckily, by Andreas, the Chief Executive Officer of the Semantic Web Company, which I'll briefly cover in a sec. And we're also covered by Mark Kitson, a Managing Principal at Capco, who runs and looks after our graph and semantic capability. On the left-hand side, we're also joined by Julia Shreve. Julia is a more recent convert to the graph world and will be moderating the panel conversation later on today. So just to give a little bit of background of the PoolParty, our partner for today's webinar. PoolParty is, PoolParty were founded in 2009, and actually were named as visionaries in Gartner's Magic Quadrant for the metadata management system. They're one of the few companies really driving forward in the graph space, and a partner of ours that we're working to try and unlock the graph and semantic space in the financial service industry. And we're very lucky to be joined us by Andreas, their CEO, today. If we can then just move on to the next slide, just before we get going into the meat of this, I just wanted to test the poll. So if everyone, if I can bring your attention again to the right-hand side, we're going to put a poll live in a sec. But one of the questions, just to gauge the audience today, is what level of intelligence are most financial service firms getting from the data they have? And again, there are 5 options here, which will keep consistent predominantly through all the polls. Almost no intelligence, competent intelligence, clever, artificial, or creepy. So if we just put that poll live, we'll just test the technology just to make sure it works and you all get a chance to use it. If you look on the right-hand side, you see that poll go live. If we can just put that poll live. See. Some people voting. So the poll isn't active. We can see people voting, which is great news. Not surprisingly, a lot of the votes are coming in at the bottom end of this: competent intelligence, almost no intelligence. We've got a little bit coming clever. We're not getting much at the top. That's not too surprising. I mean, one of the things that I find really interesting of the financial service sector, and this poll is backing this up, is actually the sheer volume of data people on the financial services have. It isn't the biggest problem bringing that data together, connecting it in a meaningful way, drawing insights from it. And sometimes we feel a little bit stuck in the old SQL world, storage, list queries. In reality, we should find better ways to network that data together, find ways to bring that in a connection, draw interesting insights, inferences around things that could be connected together, be that clients, be that internal systems, be that the way we express language. So it's a really interesting space, and obviously I'm using that language because it's very graphically centric. So looking at the poll results we've got there, which is kind of as to be expected on the lower end, And obviously, the point of today's webinar will be to cover how we think graph could be the key to that. So we move on from the poll. Thank you for that. That was a little bit of a test, but you've seen it. We're going to be doing some polls throughout it, going throughout it, and just below that is the Q&A section. You know, I mentioned a little bit before. You know, businesses are really running and drowning on the complexity of their data. You know, financial institutions are complex beasts. They're often more than one organization. You know, they're a retail bank, they're an asset manager, they're an insurance firm, and all of those have their nuances. So trying to find harmony across those or force standardization can be a real challenge. It's also a very fast evolving business, and that's not only from a regulatory perspective, but that's from a client demand. You know, we just have to look at COVID-19 to understand how clients' expectations of potential digital opportunities might be changing. That's also true for employees. You know, there is a need for greater innovation in that to keep up with it. And how do we make the digital journeys nothing, you know, more than a veneer and actually something that lives and breathes in an architecture? And as in many organizations, it tends to be that front end. And there's a huge pressure. You know, these organizations are massive risk management, there's huge cost redundancies, and all of these are business opportunities that we need to be driving. You know, as I said, data drives that. You know, we do have more data than ever, and data matters a lot. There's a real big drive to try and get more money or more value out of that data, and also understand what can be done with it. Could that be a GDPR privacy perspective? Could that be a localization agenda around different geographies? And could that be an ethical question around, you know, can I do something with the data? But the problem is most of that data is often silos, hard to access, difficult to exploit, and I would add to that, difficult to understand in many cases. You know, often the data you're using is many steps removed from the place of capture. And, you know, as it's been transformed along the journey, maybe the nuance of what that data means has been lost. So we need to get the data right. We need to get it connected. Really importantly, we need to align it with those strategic objectives of the firms. And with all of that in mind, it goes without saying, as part of this, that we believe knowledge graphs are a really important tool to do a lot of that. So with that, I'm going to hand over to Mark, who's going to talk through an introduction of the knowledge graph space and what knowledge graphs are.
Thank you, Chris. Hello, everybody. It's a genuine pleasure to share this hour with you. Graphs and knowledge graphs have been part of my focus since I had my paradigm shifted for me about 5 years ago. And as my colleagues will confirm, talking about graphs and how they could fix and are fixing financial services is one of my favorite things to do in my work time and my spare time. From the registration questions, we saw that most of the audience has either limited experience of working with knowledge graphs or no experience, and a significant number of you are outside of technology and outside of data, which confirms our view that it's actually business demand that's driving solutions in this space. So let's start with what a definition of a knowledge graph is. If you search for knowledge graph definitions, you will find many of them, some of them geekier than others. Google will point you in all likelihood to their own knowledge graph, which is a very powerful machine that helps them provide more meaningful search results. And you can see that every day when you search for things, and you'll see a panel on the right-hand side of the Google screen when you look for your favorite pizza restaurant. In terms of definition, a knowledge graph is a knowledge, which is knowledge captured as a semantic graph. It usually has an organizing ontology or schema, and it can be queried using reasoning to derive new knowledge. So let's unpack that a little bit. Knowledge in this case, we're talking about the simple facts about the real world, and these are generally declared in 3 parts, sometimes known as a triple. So thing 1 is related to thing 2. So Mark, me as an entity, has a bank account as another entity. That would be a very simple sentence and an example of a triple. Technically, you'll see these referred to as subject, predicate, object statements, nodes and edges and other nodes. The next part of the definition talks about ontologies or schema. Many of my clients and colleagues have banned me from using the word ontology, but basically it's the legend on a map. It's like a legend on a map that helps you to define types of things in the knowledge graph and the relationships and what they mean and how they can be interpreted. Over on the right-hand side, a semantic graph, key features of that are that it's a network of those facts built into those relationships as a network. Again, our friends at Google coined the phrase things, not strings, and that means that the objects in the graph, the entities in the graph, are identified uniquely, not by their labels, which can represent different languages, dialects, or the terms used between different departments in a bank, but actually by unique identifiers, and those labels become other parts of the information in the graph. Reasoning is a key feature of graphs generally, and particularly useful in knowledge graph to generate that new knowledge. That's the ability to interpret logic defined by the data and the rules of its structure, that includes the ontology, to derive new knowledge. So another way of looking at what a knowledge graph is what makes it different. So a graph, although we call it knowledge, is just data, but it's a bit different from data that most of us would work with if we do work with data. Key thing about a knowledge graph is that the relationships in a graph and therefore in a knowledge graph are called first-class citizens. They are key features of that data structure, and it makes a big difference. The way that a lot of the data that's within our financial services is built is within SQL or relational data, and their connections between things are, I guess, implied by using what are called primary key, PK, and FK joins, foreign key joins. And for anyone who's done the mental gymnastics to work with joins and then try and use them to answer questions at the bank, you'll realize that they're not really that much fun to work with. So another thing to understand about knowledge graphs is what their superpowers are. And these are the three superpowers that first drew my attention to this technology a number of years ago now. First one is expressive modeling. What you see here is a very simple representation of a hierarchy. The problem here is that you need 2 layers or 3 layers to represent this information. Well, actually, in some cases you need 2 layers, in some cases you need 3 layers, and that in itself is a ragged hierarchy. It means you don't have the right set number of layers in your hierarchy, and that is a surprisingly difficult problem for most existing data structures to handle. Just try and do it in Excel and you always end up with a few columns that you end up with duplicated data in. The multi-parent taxonomy is also a key feature, which is not shown in this diagram, but the idea where something can belong to a number of higher order objects, and graphs just do this. They're networks after all. Second superpower is self-assembly. So I don't have to sit there and design a data schema anymore. I can literally just start making statements, start making those triples, and see what the schema ontology that emerges out of that problem looks like. And I can either formalize that or I can leave it informal. That's the schemaless or schema-late feature here. But this self-assembly piece and the ability for those facts to join together within the graph without me having to write inner and outer joins is just revolutionary, and it was a breath of fresh air when I first started working with these technologies. The final superpower I've mentioned already, but I'll mention it again because it is so awesome, is automated reasoning. And the ability to join up these dots at scale is just incredible. To send a question off into your data and literally have no clue what to expect as an answer is refreshing, and then the answers themselves come back and they come back with the lines that explain how the graph came to that conclusion. So how does it feel to use a knowledge graph? It feels familiar to many of us. So you work with data, but it feels much smarter. It's like having a super smart colleague, I feel. So I think sentimentally and with great respect about great colleagues I worked with and work with today, who, if you give them a piece of information, they can return it with additional detail that really brings it to life. They can recall useful facts about a topic and make those connections between things that you might think are randomly connected, but actually explain that actually it's all associated somehow. They might know everything that matters in a particular conversation, and if they don't know the thing, they'll at least know the person that you need to go and speak to about that thing. Now, imagine if I could bring all of those colleagues I work with together into one super being and wrap them up into a queryable brain. That's the knowledge graph in my experience. It literally feels like you're working with something that's smarter than you are. and it's available when you want it to be. It doesn't go on holiday, and it's never listed on a key man risk issue list. The other benefit is that working as a team, that information is accessible consistently to many people, and you're turning that expertise of your firm into common knowledge, which is just phenomenal. And those bits of information that you're pulling out of it can, if you design it in a sensible way, come with the provenance of where the information came from, and almost a sell by date or a use by date of freshness to tell you whether the information's up to date or when it was last updated. And uniquely, compared to my dear colleagues I was sentimental about a moment ago, knowledge graphs can be corrected, and you can teach them more stuff that you want them to learn. One more superpower that I've come to appreciate more recently is how knowledge graphs partner with machine learning. We think of knowledge graphs as the next step in that path towards explainable artificial intelligence, which matters a great deal in financial services. So if we look at step 2, for those who are close to machine learning solutions or have an awareness of them, you'll be familiar with the idea that you train a black box model with some raw data and some good answers, and then the machine learning builds the model itself, but it remains a black box. And if you try, when you put new information into it, to work out why the prediction or the answer it's giving you is the answer it's giving you, you can't actually unpick that very easily. Contrast that with step 3, where if we go back to one slide, sorry, Marina, thank you. If you contrast that with step 3, what we're looking at here is the machine learning partnered with the knowledge graph, which is a form of artificial intelligence in itself, arguably. What we're seeing there is that the machine learning is doing part of the work. It's augmenting the knowledge graph to provide answers. And most importantly, for financial services use cases, particularly that explainability, those explanations. So things like GDPR and other regulations forbid the automated decision-making without the ability to explain. And ethically, many good banks that we work with have taken a stand to ensure that answers can be explained, and we applaud that. This is a PoolParty slide, and we'll quickly get on to more PoolParty information, but PoolParty have had a vision for some time about this idea of explainable AI, and of course, we invite you to follow that in more detail on the link on the page. Okay, this sounds great. Almost too good to be true. I want a knowledge graph. We all want a knowledge graph. Maybe expensive. Is it difficult to build? Time consuming? Who and how do we build them? Well, let's take a look. So knowledge graphs are built by technology, at least in part. And Gartner are forecasting that the application of graph processing and graph databases will grow at 100% annually. With that, it's no surprise that the landscape of graph vendors provided by our friends at GraphAware here on the left side of the screen is busier than ever and evolving at pace. What we do at Capco as part of our Capco Connect partner program is we monitor this landscape and we work on relationships with the best vendors that we can find and de-risk that engagement for our financial services clients, bringing valuable financial services domain expertise, because these products don't simply just serve financial services, they're used across many, many different industries. We also recognize that solutions will need different combinations of technologies in the tech stack, depending on the opportunity and obviously your firm's procurement considerations. And we maintain a number of sandbox environments where we innovate with our partners to establish tried and tested offerings. You'll see the tech stack has graphs in it, graph stores in it at the bottom right of the screen, but it has some other stuff too. And many graph stores come with these other tools, but it's worth understanding what the different components do and which tools have strengths in which areas. One of the most comprehensive and established enterprise-ready toolkits in this mix is the PoolParty Semantic Suite, which was developed by Andreas, who's on the call today, and the team at the Semantic Web Company. So let's take a closer look at PoolParty as a great example of what we would consider a mature enterprise-ready toolkit and how it helps us to build knowledge graphs. Andreas, would you mind taking us through the next couple of slides?
Yeah, sure. Thank you, Mark. Hi, everybody. So yeah, let's take a look at that slide. So first of all, what you can see here is that Semantic Suite sits as a middleware on a graph database of your choice. So that's visible on the left-hand side. And this way, it simplifies most aspects of building and using a knowledge graph. On the next slides, we will see then more in detail how the features of PoolParty on the left help to build the layers of the information architecture on the right. PoolParty seamlessly combines a powerful set of functions in 4 blocks. That is something you see on the left-hand side from back-end to front-end. What we see in green here is a graph automation that includes data ingestion and mapping, entity linking and validation, and data quality management. In blue, we have the knowledge graph management, including graph editing, as well as ontology and taxonomy management. And in gray, we see text mining and NLP, which includes functions, for instance, for text classification, for text corpus analysis, or also entity extraction and semantic enrichment. And last but not least, in orange, we see some ready-to-use semantic AI applications and other features that allow you to quickly create or integrate your own applications in third-party software. So let's take another look on the right side of this slide. So we can imagine an enterprise knowledge graph in 4 layers. And the colors correspond from the left to the right. So in yellow at the bottom, what you see there is a kind of legacy data stored in silos, structured and unstructured. And this is what we call the content and data layer. So the data will remain where it is, but thanks to the knowledge graph, it is now consistently classified and intelligently networked. And then on top, in green and gray, are the basics of your knowledge graph, which pulls data and metadata from the silos and reads unstructured data automatically. This is the so-called data graph, the component of the knowledge graph that can be generated fully automatically. And in blue, the blue layer, we use taxonomies and ontologies to connect and harmonize concepts and terms representing your business and knowledge objects. And this part of the knowledge graph should be developed by humans and not just by machines. And with regards to the quantitative share of the entire graph, this part rarely exceeds 2 or 3%. And finally, the orange layer on top, the end users, semantic AI applications or analysts, dashboards, that's typically what you see on that layer, the semantic AI application. So the technology therefore plays a major role in the creation of knowledge graphs. Potentially could be even a push button exercise, but do we really want that? So what we've seen in our 20 years or so of experience, and unlike some other vendors, we believe passionately that keeping the human in the loop with the technology is important. It's important to create business value and trust. So remembering the main 4 features of PoolParty, here we see on the right-hand side now the 3 main loops corresponding again with the components where key roles add value. So we will take a look at that step by step. The blue, the expert loop, is for knowledge engineers, taxonomists, ontologists, and subject matter experts. Then in green, again, the automation loop for data engineers or other roles like machine learning ops. And then finally, the user loop, again, in orange, for business users and data scientists. So now let's explore what each one does in turn. So first, the expert loop. So this is traditionally reserved for ontologists and taxonomists. But if you have the right, easy-to-use tools and some minimal training at hand, your subject matter experts, or sometimes called SMEs, also get to lock in some of their expertise so that it can form part of the collective wisdom in the knowledge graph. And in this view, we see those SMEs using PoolParty's semantic models to read documents, unstructured data about your domain. So in that case, really, it's kind of an automatic corpus analysis, which generates kind of a virtual circle And the SMEs organize and link the incoming concepts, provide meaning to them, and then unleash that new knowledge again to mine new terms. So it's again and again improving over time, including the knowledge of the knowledge engineers and subject matter experts, and at the same time, the machine supports with reading large collections of documents. So it doesn't take long for the knowledge graph to learn enough to become a useful companion to the SMEs, and of course that knowledge then is always added back to the knowledge graph. Another frequently seen entry point when we help customers to build the knowledge graphs is card sorting. That's a methodology to lay out the fundamental structure of an enterprise knowledge graph. It can include virtually any SME without any training upfront. That's what we typically see. And then we come to the automation loop. So much of the data we want in our knowledge graph is most likely already there. And in this loop, the data engineers map unstructured, semi-structured, and structured data into the knowledge graph. And then that's where all the graph magic then can happen. But the key to the magic is really consistent and machine interpretable metadata, methods for automatic classification, enrichment of metadata, automatic data validation, and most importantly, precise methods for linking the data at the entity level, not just at the schema level. But all these steps can only be automated cost efficiently and with sufficient precision and quality if the knowledge about the underlying relationships in a knowledge domain has already been made available by means of taxonomies and ontologies. And what you can see here with PoolParty and its unified views component, it is possible to create a virtual circle that transforms existing data into high quality knowledge graphs. And while the knowledge graphs are constantly evolving, the transformation steps can run even more precisely and autonomously. And last but not least, we come to the user loop. Just a few words about the user loop. Ultimately, the value of the graph is defined by its utility to end users, and those end users have a role to play in the graph, obviously. So they are not just data consumers, but also producers of new data and insights. And their interaction with applications powered by the knowledge graph provides a valuable opportunity to understand that value and validate what the knowledge graph holds and how it should be expanded. And the types of users could be manifold, not only end users talking to a chatbot, for instance, but also data scientists or citizen data scientists interacting, for example, with a semantic data catalog. So that's my perspective on the user loop. Mark, can you share any thoughts about the user loop in financial services?
Thanks, Andreas. Yeah, the user loop, the way that users interact with the knowledge graph is really interesting in financial services. A lot of people think they want the hairball, which is shown on the right-hand side here, the complex map of all the connections. But other than being useful for corporate art, it's usually too overwhelmingly complex to be of significant use. Having said that, there are ways to filter and use subsections of it that can be useful. I think that the one that I would highlight is we are increasingly using the knowledge graph to populate the familiar sort of grid-like structures that people in banking have loved for decades, kind of pivot table-like matrix views. And then, of course, for most users, what they will see is improved search capabilities, that Google-like experience of putting a question into the internet and getting a useful answer as opposed to what some of us might experience today. Let's look at some use cases in financial services. The good news is that we are seeing use cases from across the enterprise. The data has officially left the Chief Data Officer's office and is now all over the firm. Who knew? One of the themes that we're excited about at Capco is a family of enterprise knowledge graphs we call digital twins. Digital twins have been around various industries for a long time. Effectively, they're just digital replicas of complex real-world systems. If you're building it, if you're GE jet engine company and you build a jet engine, you know how that jet engine is supposed to work, and you can easily create a replica of it. A bank is slightly more complicated with nuances and departments and humans and all sorts of other complicated, smushy things. The building a digital twin of that was pretty difficult. Knowledge graphs make it possible, and we're excited about different use cases for that. There are two main areas that I think we're most excited about. I'll talk about one, and I'll hand over to Chris to talk about another. My particular favorite, has been a favorite for a number of years, is the idea of an enterprise digital twin, which we're seeing here in the middle of the left column. That's generally something that business managers and risk managers of a business would be interested in, and it's a self-assembling model of big parts or layers of the firm. We're seeing use cases around that to help transformation initiatives, but also with reference to the box on the top right of the diagram here, operational resilience, where the digital twin becomes, we add a couple of extra layers on there to help understand how that organization needs to react during crises. Chris, are you ready to talk about your favorite on this diagram?
Yeah, sure. I mean, my favorite use case, as everyone has a favorite graph use case, is something we refer to as deep cloud insight, which is really using the idea of a network graph kind of view to look at our customers. So
this is basically KYC on steroids, and in a sort of perpetual smart event monitoring way. The idea that clients live as isolated individuals really isn't a true representation of reality. They are in fact deeply embedded in networks of their own families and households, networks of clients and suppliers, and understanding those networks gives us a really valuable opportunity to manage risk better, but also to sell exciting new products. So yeah, that's really exciting set of use cases. We will be showcasing some of these use cases in later versions of this knowledge graph webinar series. I think we'll be doing a deeper dive on digital twins and deep client insights, and excited to discuss any others that are of interest to the audience on follow-up conversations after this call. So we're all excited about these things. How do we get started? And for those who have already started, how do we scale to success? Andreas, I'm going to ask you to tap into your 20 years of experience and tell us what you've learned are the key considerations when getting going with graphs.
Yeah, sure. So what you see here in front of you are really 5 core principles, 5 steps in order to be successful with that. One principle is really to start small and grow to a big vision. So initially, we typically provide companies with a so-called semantic web starter kit. Those are POCs based on concrete use cases and data embedded in a larger plan of how knowledge graphs will improve and drive overall content and data management in the long term. So it's small on the one side, but it always has a bigger vision included. That's very important. Step 2, get to know your data. So the next thing you need to do is gain a good overview of your data landscape. So there are different approaches for inventorying and organizing enterprise data to determine which types of content are relevant to your use case. Consult with subject matter experts and analyze your data. Use taxonomies and ontologies to classify content and to organize your data catalog. And then step 3, very important, form a working team. It should be the right mix of skills. Bringing SMEs, taxonomists, and data engineers together is of course key, but also involving business users and citizen data scientists as soon as possible is essential, since they will become an integral part of the continuous knowledge graph development process, nurturing the graph with change requests later on and suggestions for improvement. And then we have step 4, map relationships across your data. I guess that was already explained to a certain degree in the expert loop and automation loop in more detail. But remember, most of the mappings and linking steps can be automated, but only when high quality ontologies and taxonomies are available. And last but not least, stay agile. Most likely you will be successful already with your first pilot application built on graphs. At least that's what we've seen frequently. More than 85% really are successful, those POCs. So you will have excited several stakeholders in your company, and even non-technical people have quickly grasped the beauty of graph technologies. So people from other departments start asking what is in for them. And now you are in a critical phase, as you may want to try to make the big change and plan it for the next 20 years. Don't do that. Experiment in order to make valid decisions based on experience. Learn that experiments are not bad things or even a sign of immaturity, but rather the only chance to learn, to become better, and to improve continuously and to develop skills. Knowledge graphs help to become an agile and learning organization. Yeah, and that also brought us to write a book. In April 2020, we finally published the first edition of the Knowledge Graph Cookbook. And you can get a copy for free from the PoolParty website or on Amazon, a Kindle or a paperback. People say it's right up to date, but still based on more than 20 years of experience. And just yesterday, we received a really nice feedback from a senior information architect working at a major broadcasting company of Europe. And he said, it's the book I was subconsciously hoping for in the last 5 years. It would have saved months of searching and reading to me, but it will save lots of time in the future while evangelizing our business towards information-driven enterprises. The book also includes 11 expert interviews, and including some thoughts from Capco. Mark, how did you like the book?
Yeah, Andreas, thanks for interviewing us. It's a real honor to be able to contribute to it. I find the book to be very accessible. It's a great balance of more technical concepts and advice. And then, of course, there's the fun culinary twist, which always makes me a bit hungry for more. And it's. I think we all saw the warm reception the book had on launch. It was on Amazon bestseller lists and so on. But again, friends of PoolParty and Capco can get a free PDF if you ask the right people in the right way. Moving on to specific lessons I've learned from building graphs in financial services. I think what strikes me is that most people in banking naturally think and sketch in graphs, in related entities, boxes and arrows. They're natural graph designers. That's the way they think, that's the way they see the world. And then we pass over our data to the data modelers who, again, unfortunately, go back to the tools that they have and that they know very well, those SQL tools, and start to shed knowledge and shed context because they're stuck with these joins and maybe they don't know or they're not willing to look at other options. The quote here I like from Albert Einstein, which is, we cannot solve the problems with the same thinking we use to create them. I think that is part of the problem here. And the inertia around this in financial services is significant. Many data and technology people have built their careers on their ability to model data. And unfortunately, at the moment, it's just not necessary to be shedding as much of that context as we work with data in financial services. One other observation I would just add on the next slide is, I suppose, a partly baked thought, which for me is maybe an excuse as to why I haven't been able to get more people to love knowledge graphs in financial services until I think this year we're seeing this huge uptick in interest. And this is one around complexity. So complexity grows as a natural part of the way we do business. On the left side here, we see two kind of complexity curves. One is more of a step shape, and the other one is an incremental, almost exponential growth curve. And I think the observation I would make is that personally, and the groups I work with, have a threshold of complexity that we can handle with the tools and the brains that we have. And somewhere on these lines, we get to a point where the complexity is too much for us. And I'm always tempted to put my hand up and say, oh, I'm a bit stuck here, I can't do much. But then I always look at my smart colleague. And if I admit that this is too complicated for me, then maybe I won't get that job or that raise that I was hoping for. But we can have a debate offline as to whether the line for the group and the group's ability to handle complexity is above or below mine as an individual. I think I know where it stands, but those lines are there on the left. So my response to this growing complexity and my feeling is that banks and financial services firms are in many ways too complex for us to handle as individuals, is either to stop and give up, push on and burn out, blame the tools or others, or seek help and seek new tools. And when I did that, I found knowledge graphs. So I think financial services firms have an opportunity to call out that complexity and recognise that opportunity to use different technologies and tools. So I think we're now ready to move to the panel, and following that, the open Q&A. I'll hand over to Julia. Julia, are you there?
Hey, Mark. Yes, I'm on. Hey, Mark. Does everyone hear me? Right. So thanks for that. I think that was...
hear you. Let's dive into these questions.
Great. Yeah. So that was a really great discussion. Thanks for that. So just for everyone who can see, there's some questions already being submitted from the audience. The Q&A box is just on the bottom right there, just in the panel for any questions. So some good questions coming in. I'm just going to kick off with a question though. Andreas, apart from the sort of digital twin examples that have been highlighted by Mark and Chris, which use cases do you think you're most excited about in financial services?
Good question. So I think one, it really is deep text analytics, because there's so much unstructured information around. And with simple text mining services, it's really not possible really to get to know what's in the document. And with a knowledge graph in place, you can complement text mining algorithms with a lot of background knowledge, and graphs can do even better than other data structures and knowledge models. Mark highlighted a couple of those, like reasoning and stuff. So deep text analytics as a combined approach where graphs, machine learning, and NLP techniques are fused can do very well with, for instance, screening legal documents and many other types of documents which are totally unstructured or only semi-structured. So that would be one. And the other one I can think of really is semantic data catalogs. I think this is so important to have better ways to catalog data at the beginning of each project, but of course also in the long run to have a really good access layer to all the data available with a uniform, consistent view on all the metadata. So combining data catalog techniques with semantics and knowledge graphs is a second very important use case for financial services, I guess.
Okay, thanks, Andreas. I guess just picking up one of the questions from the audience here, one from Ian McLeod here. The question here, if most of your knowledge is in spreadsheets and emails, how do we go about accessing it? Mark, what do you think on that one?
So I'd think of that in two phases. One is if it's a quick proof of concept, just being able to twist that data, just convert it into triples and put it into one of the basic graph visualization tools. I think it's a very quick step, and you can do that within a matter of hours. The tools that Andreas has talked about here, whether it's using something as mature as the PoolParty Suite, or you can roll your own tools. They are there, and most of the graph databases have techniques in them to pull in that data to map to traditional structures. Excel tends to be relatively well structured, although it always has unexpected trailing white spaces and all that kind of fun. And then the documents with the deep text analytics capabilities that Andreas mentioned can be consumed, certainly for looking for mentions of key topics and things like that. So depending on where you are in the timeline, there are definitely some very easy and attractive options.
Thanks, Mark. I have a question for you next, Chris. So I guess just taking up a level a moment. So obviously you spend a lot of time with financial services clients across data, technology, and the business. What are they interested in? How direct is their understanding of knowledge graph's potential to help?
Yeah, so actually a really good question. I think ultimately we've got to ground this in the business problems they're understanding. So the business problems are often understanding complex networks. So if we think about a lot of people, if you take the COO spaces, they want to understand what their organizations are doing, and they're realizing the paper trails aren't effective. So they're seeing knowledge graph as an interesting way to do that. Particularly we talk about the digital twin there. If you kind of move over to the kind of CTO space, they have complex estates of IT, data flows, they have outages, all kinds of stuff. And again, finding the right technology to look at that problem is a really important thing, and we're starting to see people move that way. If you go on to the more business side, the interesting one there again is they all want to understand, what are the customers doing? How do you get to a single view of customer? How are those customers transacting with you? How are they related to each other? So, I would take a step back and say that ultimately the senior management are less interested particularly in graph. They're interested in the business outcomes they can get. And that will normally default them back to pivoting towards some of the graph-based solutions that we're seeing. And that journey, as Mark said earlier, seems to be picking up a real pace this year.
Thanks, Chris. I guess just leading on from that question from Kevin Howe here on the Q&A. So Kevin's asking, how can you share a good example of a small scale project for step one? Basically, what's a good starter here, and how can we start to dip our toes in the knowledge graph pool and actually give a good platform for scaling?
I mean, look, I think the interesting thing about graph is we need to look at it as an iterative build process. Where actually we start small and build, and actually where you start, is often going to be related to you. But some of the interesting places we've seen organizations start is we've seen them starting related to some of the single view of customer, entity resolution pages. We've seen it start over there. We've seen many people start in the kind of data flows, so taking their data catalogs and data flows work they may have done for certain BCBS 239 CCAR regulations, and look to pivot that into a graph. We've seen some real good success in people then looking at that from like a business resilience perspective. There's quite a few places to start, and I guess it all really depends on your organization. If you're lucky enough to have a well-defined data dictionary and a lot of flows, I'd suggest you go there. If not, I would look for the small, really valuable business problems. I mean, we've even had conversations with some clients around looking at training and how people's organization constructs might map to policies and through onto training requirements. There's lots of these little opportunities to build those use cases. I think the key thing is once you've built the first one is to not treat that as throwaway work and treat that as iteratives. Now I've built a set of data assets which I can build on. So necessarily, I know I'm answering the question a slightly different way, but the starting point maybe isn't always as important as the way you go about it.
Yeah, I think you made a good point there, Chris. I mean, being relatively sort of newer to the world of graph thinking technologies, I think for me, once you get your head around kind of building blocks, it does become very accessible, and you do start spotting use cases everywhere. Whether you're connecting people, processes, systems, the possibilities do become endless. I think, unlike many other sort of tech trends out there is an easy path to start small, prove value, and then start to scale. I guess you did mention well-defined data. So I'm just picking out a question here from Andrew Foster here, where he's asking, so what approach do you take to data quality cleansing? What degree of automation is there? Mark, any thoughts on that one? Because obviously that's critical in terms of embedding and looking to scale.
Sure. So I think if we think back to the information architecture Andreas outlined one of the earlier slides, there's a concept and linguistics layer in there. And linguistics, we often think about in terms of English versus maybe French or Spanish, but there's also people who know how to spell and people who don't know how to spell. So you can often use some of those features to absorb some of those misspellings of the United Kingdom, people's nationalities, or any other elements of information that should be captured consistently, but isn't always captured consistently. And graphs are naturally capable of absorbing that sort of inconsistency, particularly where it is a frequently occurring value.
I can add something here. So it's what Mark said. Of course, on the property level, the linguistic part of the knowledge graph is something you can greatly qualify and validate, but it's more than that, of course, because the whole structure of the graph can be validated against so-called shapes. And this is also a great opportunity to do data quality checks automatically when data is linked from different data silos.
Thanks, Andreas. Just picking up just on a question here from Ian there, just in terms of actually bringing this to life. So Ian's asking, what are the advantages of using a product like PoolParty over installing a package for an open tool like R programming? So we just dig a bit more into actually bringing graph solutions to life. What are your thoughts on that one, Andreas?
Yeah, that's a frequently asked question, really, and of course it makes sense to discuss that. But one quick answer on that is you can include SMEs, subject matter experts, in the process when you have tools like PoolParty, because they provide quite intuitive user interfaces, and the expression of many knowledge pieces in a certain domain can be done via drag and drop. And when including SMEs like lawyers or geologists and so on, who are not able to write any R or any other machine learning code, it's hard to include them in the process, and you lose a lot of knowledge by that.
And just on the topic of modeling, of coding and modeling, Andreas, there's a question here from Sun Cook Han.
The question was, at the moment, two types of modeling are popular: RDF and label property graph. What do you think is more appropriate for enterprise knowledge graphs?
I think it's a great question. I know what Andreas will say if we ask him, so I suggest we hold that one. It's one of those Pepsi and Coke kind of debates, if I can mention those two brands. I think a lot depends on what tools you have available to yourself. If I had to make a choice today, I would look quite carefully at an RDF solution myself. PoolParty, I think, is naturally heading in that direction. There are other options out there, definitely worth having a conversation about, but not one I think we'll be able to provide a definitive answer that everyone will be happy with on this call.
Thanks, Mark. I mean, look, we're running out of time here. There's a lot of questions, so I'd like to thank the audience for all these questions. Anyone who's named, we're going to get back to you offline if we don't cover it. We have a little bit more time to cover. I think probably one or two more questions before we wrap up. There was a good question here from Robert. I can't apologize, I'm really bad at pronouncing names, but the question was, what's your opinion about fiber and the role it plays in the financial domain, any fiber use cases? I mean, look, I'm a really political question to answer here, really, but, you know, fiber is an ontology. There are also many other ontologies. I think it's a great, you know, they can be great starters, you know, for building your knowledge graph on. And fiber, it has good coverage of a range of things that might be useful. There are other examples like the common data model that's published by ISA. You know, I think we should look at any one of those areas as a very domain-focused accelerator. So, for example, fiber is pretty good in the contracting space. It's pretty good in the transaction reporting space. If you look at things like the common data model, it's pretty good on the confirmations. So using those are really good ways to accelerate in a particular domain. I mean, the great news I personally feel about Fibo is that, you know, they are building a much bigger open source approach, which they're trying to gather more domain expertise and therefore build on that knowledge. But I would treat any of those as kind of domain specific accelerators. And then let's just bring one more question before we wrap up. There was a question here from Sean McHenry, if I'm pronouncing that correctly. How do you integrate additional business metadata tools, repository, and knowledge graph capability? Are they opposing or can they be complementary? Mark, do you have a view on that?
Absolutely. I think the answer quickly is complementary. I think one of the things that we're not saying here is that you've got to stop using everything you're using and start using only graphs from now on. I think we absolutely see them as something that sits alongside everything you've got today and helps fill in some of those capabilities that those tools simply cannot provide. If I think about some of the popular data governance tools that are out there, you know, we readily see people, and we're helping clients as well, to put a graph capability alongside that to enhance what those things do. And I think that's absolutely the direction of travel for the foreseeable future. It also makes the implementation significantly easier. So a lot of the technology actually work is done in the background, and what clients see is an uptick in value and in the quality of results. So absolutely, it's a combination of those metadata tools and the graph capabilities that give you that reasoning capability, that self-assembly, that precision, that ability to connect the dots that some of those very well established and mature metadata management tools just aren't built to offer.
Thanks, Mark. We are kind of wrapping up here, so I'll bring this to a close. I mean, there are a number of questions that we didn't get to. So first of all, again, thank you everyone for submitting the questions. We do see an interactive audience, which is great. And if we've not answered your question, we will endeavour to get back to you offline. So please watch out for that. Just so you know, this is one in a series, so we are going to be looking at a range of webinars in this. So there's a couple more to look out here. We will be running one showcase, particularly on digital twins, and another one on the client insights. Those are 2 use cases we covered earlier. They're going to be in mid-September, mid-November. So watch out for those dates. And apart from that, I'd just like to thank you for joining. I mean, I'm going to reiterate that, we genuinely believe that this kind of technology will be, a very significant part of strategies for the financial services going forward, and will be, as we've said in some of this, the kind of secret sauce that organisations will use to unlock the value of their data, or at least bring it together in a way that they can generate meaningful insights. And I'd like to thank everyone for attending today. This will be recorded, or it is being recorded. It will be out on the web shortly, and we look forward to hosting you at our next webinars to come up in mid-September and November. Thank you, everyone, today, and everyone have a good rest of the day.